Okay, here we go. So the next topic we're going to get into in the RS500 sequence here would be the RS500 timers and counters. Spend a little bit of time on these. We'll do a couple of short demos, give you guys an idea of how these actually work. Oops, sorry about that. All right, so first off, the big thing I want you to realize as you're taking exams in here or trying to figure out what are timers and counters really for? Well, timers are there to time intervals. So keywords, tricky phrases here. Timers, time intervals. You may see that again on a test here real soon. And counters, count events. So what we mean is, if I want to time the amount of time between when I hit start and when a motor starts, or when I hit stop and when a motor stops, that's the interval between when that event occurs and something else. Counters actually count events, so you can think of like a parking ramp. Every time a car comes into a parking ramp, I count the car. Eventually, I know when the lot's full or something like that. So there's events, there's intervals. We time intervals and we count events is what we do. When it comes to timing and counting instructions, the world of RS500, these are our key instructions. We have an on delay timer, we have an off delay timer, we have a retentive on delay timer, we have an up counter, we have a down counter, and then it's not really a counter or timer, but the reset instruction becomes very important as we're working with counters and timers in the RS500 software. So a couple of things here. Some of the timer bits. I'm not too concerned about the bit numbers. You can look these up in the instruction help if you want to look them up and see what they are. I'm a little more concerned with what are these bits. This is what's important to me. When you're dealing with a timer is what we call a box instruction. And all timers in RS500 are going to be addressed T4:0. Oops, sorry about that. T4:0, T4:1, and so on. T4:2. So I can continue to use timers, ... But when I want to address a bit, it's going to be addressed as T4:0 / done, or T4:0 / timer timing, or T4:0 / enable. What that means is when the timer has expired, or when I got to be careful on expired here, because in the case of an off delay timer, the done bit turns on immediately. So what I will say is there's a done bit associated with every timer. Okay, and the way the timers work vary a little bit, but there is a done bit for all of them. The timer timing bit, anytime the timer is actively timing. So if I have a 10-second timer and I've enabled that timer and it starts counting from 0 to 10, that timer timing bit is going to be true. And then the enable bit is anytime the timer is enabled, meaning the run leading up to it goes true. That's when the enable bit is going to go true. So let's get into this a little bit here. So here we can see we have a timer. Okay, so we have an on delay timer, TON, and we can see the address of this timer is T4:1. It has a time base of 1 second. It has a preset of 400. Right now it hasn't accumulated any time, so it's not timing, it's not enabled, it's not done. When we talk about timer addresses, so we can start out at T4:0, but T4:X means I can go all the way up from T40 all the way up to T4:255. The time base that you see here, there's several different time bases I can use. 0.001, or what would be equivalent of a 1 millisecond time base, a 10 millisecond time base, and then a 1 second time base. So that's the time base. The preset that you see here can be a number. It's an integer. It has to be an integer, 16-bit integer. Therefore, it goes from 0 to 3267. You might say, well, where does that 3267 come from? Well, if you remember, we can do that 2 to the 16, right? Let's take a look at that real quick. Keep my annotations here for a second. Drop my pen. All right, let's go scientific. 2 to the 16 equals 65,536. Let me grab my pen. Where to go? There it is. And so you say, well, where does that 32,767 come from? Well, the 32,767, that is our max time, actually comes from the fact that that 65,536 goes from negative 32,768 to positive 32,767. So when we're talking about integers in RSLogix 500, we go from negative 32,768 to positive 32,767. So that's where that goes. Now, why don't we go down to negative 32,768? Because we can't have a negative value for time. When we get to counters, we can, however, have a negative value for count. So that is something that's a little bit different. We will be able to use the full spectrum of the integer range for that. And then the accumulated value is what the current accumulated value is. So when the timer starts timing, it will display where it's at in that timing sequence. All right, so now let's talk about these things. So we've got a preset, we've got a time base, and then we have a time delay. And it's actually very, very simple. I take the preset, which again is this number that you can type into the timer. So a timer 4-1, I'm going to set in a preset of 400, and I'm going to select time base 1. So I would take the preset, I would multiply it by the time base, and that's going to give me my time delay. Very, very simple. So if I have a time base of 1 second, and my preset means I'm going to have 400 of those, then this is going to be a 400-second timer, right? By contrast, again, if this is what multiplied by 0.01 is going to give me 60, this is some value of x, well, now I can take 60 divided by 0.01, and I'm going to get 6,000. 6,000 times 0.01 would give me 60 seconds. Or in this case, if I had 32,000 and I wanted to get to a 32-second timer, I would multiply by 0.001, and I would get to a 32-second timer. And then I think it's pretty obvious on this last one here. Again, multiply. What times 1 equals 13? Or 13 divided by 1 equals what? Well, it's equal to 13. Remember this preset, though, is what? This preset is an integer. Remember that. It can only go from 0 to 32,767. The time base is either going to be 0.001, 0.01, or 1.0. And then your time delay is based upon whatever these two numbers multiplied by each other equal is what we're after there. So should be pretty easy to figure out. All right, let's talk about the different types of timers. The on-delay timer. So what the on-delay timer does, and I like to explain it this way. I have a rung right here, and I'm going to have a bit that's going to enable this timer, okay? So we'll call this, this is my enable for the timer. So the way the on-delay timer works is when the enable goes true, boom, that's when I start timing. So at that point, the timer timing bit is going to start timing. But think of what we're doing here. So this is when I'm going to start timing. This is an on delay. So I'm going to wait to turn on the done bit. So in this case, I have a 400-second delay. So that time is going to be a time here before I'm going to, well, and actually I got to be careful here. Let me erase this for a second. I don't want to screw you up here. I'm actually showing the done bit there a little too soon. Let me get rid of that. All right. Well, let's keep those. Sorry about that. And go back in here and go back to my annotation here. I want my pen back. Okay. So the timer timing bit, as soon as the enable goes true, the timer timing bit turns on instantaneously. Oops. Sorry about that. Oh, crud. So the timer timing bit's going to turn on instantaneously as soon as the enable goes true. The done bit, though, however, that is going to wait. So, this is when I started timing right here. So the timer is timing, and it's counting from the accumulated values going 0, 1, 2, 3, 4, and it's going, in this case, it's going to go up to 400 seconds. So there's a time delay that I'm going to call time t between when the done bit goes from 0 to turning on. Okay, so if you think of this as, the enable going from a 0 to 1, the timer timing bit going from a 0 to 1, and the done bit going from a 0 to 1. as soon as I enable the timer, as soon as this bit goes true right here, the timer timing bit turns on with the enable bit. The accumulated value is going to start accumulating, but the done bit isn't going to turn on until my accumulated value is equal to my preset value. At that point, the timer timing bit is going to turn off because we're no longer timing. The done bit will stay on, but only until that enable goes back to 0. As soon as that enable goes back to 0, your done bit also goes back to 0. So what have we done? Well, what we've done is we've created an on delay. I've enabled the timer, and I've waited an on delay before my done bit goes on. Okay? Let's look at the next one here. This is the off delay timer. So the enable for the off delay, so again, we enable this bit right here. I'll call this my enable. I'll just call it yen for enable. When I enable this, I basically take that terminal from 0 to 1. I make that rung true. When I do that, the timer timing bit is actually going to stay down here. But what's strange, and this is the one that's going to screw people up the most when they first start using it, is the done bit. With an off delay timer, the done bit turns on immediately when the enable goes true. So I can see the done bit goes 0 to 1 with the enable. So when this went true, the done bit turned on immediately. Okay, as soon as the enable goes false, goes back down to a 0. When the enable goes false, that is when the timer timing bit is going to turn on. Okay, that's when we're going to start timing, and we're going to delay turning something off. So we're going to keep the done bit high, and we're going to delay turning that done bit on until we've reached whatever that time t is, and then we're going to shut it off. So the timer timing bit is going to time, and when we reach the accumulated value reaches a 200, that's when the done bit will turn off. So what we've done is we've enabled this thing, the done bit turned on immediately, and now when we took the enable away, we delayed turning the done bit off for some set time t, in this case 200 seconds we'll say. Okay, compare that to the last one where we delayed turning it on, and that one was 400 seconds, but we delayed turning on. And notice when the timer timing bit is on too. It's the timer timing bit is on when we are accumulating time. Okay, whether it's on the on delay or the off delay. All right, retentive on delay. All right, let's look at this guy. This guy actually is an on delay timer. He's no different than what we did before. I enable him. Okay, my timer timing bit is going to turn on immediately because he's an on delay timer. My done bit is not going to turn on, but what's going to happen with my done bit is I'm going to start timing, right? I'm going to wait some time t before I turn on my done bit. Now my done bit is on as well. So remember, these are 0 to 1 transitions. The enable bit controls everything. So the enable goes on, timer timing bit turns on. Once I've reached the time t, my done bit's going to turn on. Okay, my timer timing bit is actually going to turn off, so kind of ignore that part. My timer timing bit is turning off. My enable is still on. Okay, when my enable goes false, because this is retentive, it retains the time t, the accumulated value. So normally I would shut off right here on an on delay timer. This is maintained. The only way I can get this to go back down to a 0 would be I require a reset instruction to take this back down to 0. And we'll show you that here in a few minutes. Because it's retentive, it's going to hold that time until I have a separate instruction that resets the timer. So it's a retentive on delay. It looks just like the on delay. Enable on, timer timing on, I wait a time of t. Enable on, timer timing on, I wait a time of t. The only difference is when I lose the enable, I maintain the done bit on, and the only way I can get back to 0 is with a reset instruction. All right, so let's do a real quick timer demo here. I think this is, we can talk about them all day long, but until we actually look at them, I think it doesn't make a whole lot of sense. I'm going to real quick, I've got a little micrologics here, so I'm not running the same PLC that you guys are in the lab. I'm just going to auto configure, make sure I'm talking here. It looks good. And I'm going to go into RS500. All right. Before I, oops, sorry about that. Before I run this, what I want to do is I don't want to just run it. I'm going to actually build it in front of you here. So I'm going to delete these two rungs. Okay, one of the things to notice as we start building here is we have a lot of files over on the left here. So our output files, we call them the zero data files. Input files are I1, status files are S2, binary files are B3. We'll get deeper and deeper into this as we use all the different instructions, but what we're going to use right now are the timer files, T4. So in doing that, I'm going to drop in a couple rungs. So here's a rung, and here's a rung, and then I'm going to drop in a bit. And on my PLC, my first input is I00, and then I'll do an output down here of O00 as well. So with the micrologic, it's a little bit different. Don't let the addressing screw you up. It's the exact same logic that we're doing. Now, instead of being under user a bit, which we've been in primarily, we've done the latch on latch and output enable instructions. I want you to go to the timer counter tab up here. First thing we're going to do is we're going to grab a TON timer. I'm going to drag that TON timer like an output instruction. I'm going to put it on the right hand side of the rung here, and it's what we call a box instruction. I can see that it's asking for a timer address. Well, I know T4 is my first address, so I'm going to address it as T4, and it's actually telling me, it'll give me the first one, but I'm going to type in :0. All right. And let's say I want this thing to be a 1 second timer. So the time, or excuse me, not a 1 second timer, but a timer with a 1 second time base. And let's say I want it to time for 5 seconds. So then I would set my preset by typing in number 5. So now 1 times 5 gives me a 5 second timer. Now if I want to use this timer, what I will do, and I'll actually throw in one more rung here, I think. Let's throw another rung right here. And I'm going to put another output here. Sorry about that. I'm going to move this one up. And I'll call this the next output, which is going to be 1. And I'm going to put 2 bits in here. I'm going to drag a bit in to this rung. I'm going to drag a bit into this rung. And the 2 main bits that we like to use are the timer timing bit and the done bit. Now, a couple of ways you can do that. You could double click in here and you could write T4:0/TT for timer timing, that bit. And I could go here, I could type in T4:0/DN for the done bit. And that's going to work out just great. I'm going to address those a little differently, though. I'll show you another way you can do that. I can also go in to the timer files over here. So the data files associated with timers. If I go into the data files associated with timers, I can see it lists all the possible addresses here I can get, right? It's only going out to 39 right now, but I can add them as I needed. I'm going to go ahead and grab the T40, but I want the timer timing bit. I'm just going to click on that and drag that guy in. And the done bit, I'm going to click on that and I'm going to drag that guy in. What's neat about this is you can actually watch the status of these bits in here if you like, to see what they're going to do. And now I'm going to go ahead and go to download. And before I download, I'm going to verify my file like we do. No errors found. And then I'm going to go to download and hit OK. Downloading the program. It says, yep, we're going to throw that on your PLC here. And then go back to run mode. I'm going to go online with this thing. You can see nothing's running right now. And I'm going to real quick move over to where my switch is here. But I want you to take note here. I'm going to turn this switch on. You'll watch the timer start timing to 5 seconds. So watch the accumulated value is going to go up. 1, 2, 3, 4, 5. The done bit turns on down here. And we see this output turn on. if I turn off my enable here, the timer accumulated value is going to reset back to 0. If I do it again, this time let's not look up here this time. This time let's look down at timer timing and done. So when I first turn this thing on, the timer timing bit turns on, 1, 1000, 2, 1000, 3, 1000, 4, 1000, 5, 1000. Then the done bit turns on. As soon as I turn off the enable, everything resets. So we have an on delay. From the time I turn this on until I get the done bit, it's a 5-second delay turning on the done bit. Okay. Now let's look at this a little bit different with our TOF. If I want to change this to a TOF, all I have to do is just go up here where it says TON and I can just type in TOF. And now it's an off delay timer instead of an on delay timer. I'm going to give myself a little bit more time. I think that one, this one's going to take a little bit more explanation. I'll go to download. Different timer, so we need to download it again here. Now we've downloaded this into the system. We go back to run mode, we go online, and same rules apply, except this time I have a 10-second timer because I changed the preset to 10. But remember what the off delay timer does. The on delay delayed turning on the done bit. The off delay is going to delay turning off the done bit. What that means is when I enable this, the done bit's going to go true immediately. And then what I'm going to do is I'm going to keep the done bit on after I take the enable away. So first thing I'm going to do is I turn on my enable. Notice the done bit is on immediately. The done bit is on. And I'm not timing at this point. Why? Because it's an off delay timer. When I shut my enable off here with this switch, we're going to start, this thing's going to start accumulating. I go off, now the timer's timing. This is going to accumulate up to 10, but we are maintaining the done bit on. We are creating an off delay of 10 seconds before the done bit goes away. And only when the accumulated value is increasing, whether it's on delay or off delay, those are the only times that the timer timing bit's going to be on. Whether you're counting up or counting, I won't say counting up or counting down, whether you're counting an on delay or counting an off delay, only when that timer accumulated value is accumulating are we actually going to see the timer timing bit go on. So I'm going to go offline and show you the last one here. The last one is the RTO. All right, and let's download this guy real quick, and you'll see something a little bit unique about this one. We'll go online here, and there we go. So this is an RTO. It's an on delay, retentive time on, retentive timer on. So it's still an on delay timer, but it retains the time. What that means is I'll turn this guy on, timer timing bit turns on just like a normal on delay. It's going to start to increase in time all the way up to 10 seconds, and then the done bit's going to turn on just like a normal on delay. Now my done bit's on. But now watch when my enable, normally on an on delay, when I turn the enable off, the done bit turns back off, the accumulated value goes back to 0, but on a retentive, if I turn it off, it does not. This comes in handy if I ever want to, let's say, it's kind of like driving your car, right? Let's say I want to have an accumulated value of 3,000 miles on my car and I want to change the oil. Well, it would be sad if I ran the car for, a 200-mile trip, and then when I shut it off, the odometer went back to 0. I would never be able to get to $3,000. I want to retain that value. But maybe when I get to 3,000 and I get the oil changed, I might want to reset that. So that, that's a mile counter, really. It's not actually a timer, but it's the same idea. I want to add up to a time. So even though I may get a pulse for a short period of time, 5-6 seconds, and then later on I get 10 seconds, and later on I get 30 seconds, maybe it is when I get 900 seconds, I want something to happen. So I don't want to lose this accumulated value just because the enable went away. But now you ask, well, how do I reset that accumulated value? How do I get rid of the done bit? Well, I don't have a way to right now. What I need to do is I need to go offline, and I need to create another rung where I can get rid of that value. And what we do that with is by creating a rung, and you go to timers and counters, you'll see the RES instruction in here. So you have TON, TOF, RTO, you know, on delay timer, off delay timer, retentive on delay timer. Then we have our counters. Then we have a reset instruction. I'm going to grab that reset instruction and pull it down here. And I'm going to address it to T4:0. So I'm going to go ahead and go here and go T4:0. And so I'm going to reset the timer. And I'm going to reset it maybe with a different bit, meaning I'll use a different input, like a master reset bit. So this will be in, and I'll use whatever the next input address is here. And I'll download this. And now when we go to use this, this should work out pretty well for us. Here we go, we're downloading. And by sheer value of downloading, we did reset the timer. But now we're online, and I go ahead and start timing. It's going to time up to 10 seconds. Timer timing bit's on because I've enabled, and it's accumulating. When I get to 10 seconds, you'll notice that the done bit turns on. And now I'm going to take the enable away, and just like before, the cumulative value stays even though I took the enable away. But now because I have this reset instruction, if I turn on I:0/1, boom, the timer's done bit de-energized, and the accumulated value went back to 0, and now I can use this timer again. Be careful. You don't want to ever leave this reset on. If you leave this reset on, the timer won't time. So like even though I've got the timer enabled right now, because I've got the reset instruction true, it's not going to time. So I need to make sure that that reset is turned off after I'm done resetting the timer, so I can go back and start timing again. So, all right, so that's the basics of our timer. And again, we'll talk a lot more about this in the lecture class on Tuesday. But let's go ahead and go back into the PowerPoint here real quick, and let's talk about a few of our other instructions. The counting instruction. So we did our timer demo, we did our on delay, our off delay, and our retentive. Now we're going to go into the counting instructions. And basically there's two directions you can count. You can count up and you can count down. Similar to what we did with the timers, there are bits associated with counter instructions. I'm not too concerned with these bit numbers. I don't care. But I'm concerned with what these bits do. So counter addresses are going to have an address of C5. So you could go C5:0, C5:1, all the way up to C5:255, right? Dot, dot, dot in the middle here. And then we can address these bits to them, like C5:3/done, or count up. The done bit's probably the most important for our counters. But we also have some neat bits here. So some people, want to know, well, we can only count up to 32,767, right? Well, that's true. However, we could turn on a bit if we go greater than 32,767, and we could turn on a bit if we ever go under negative 32,768. So we would know that we're actually above 32,767 or below negative 32,768 if one of these bits turned on. So it gives you the ability to kind of actually count beyond, because what's going to happen is they're going to, when you do this 32,768 here, or 32,767, basically you started at 0, you went all the way to 32,767, and then the next number you're going to get is negative 32,768. Boom. And then you're going to go all the way negative 32,767, negative 32,766, all the way back to 0 and all the way back up. So theoretically, you can count beyond 32,767 or below negative 32,768 if you choose to. All right, counter addressing, and we kind of mentioned this already. C5, that's our counter data files, and we start at C50, C51, C52, C53, C54, so on and so forth, all the way up to C5:255. The preset is a 16-bit integer again, negative 32.7 to positive 32,767. So this is an important number both for timers and counters. The difference now is we actually can go into negative values with counts. And then the accumulated value .acc is a number that we can address later on as well. For right now, we're just going to concern ourselves with the done bit, but we can also use things like compare instructions and say, I want to know when the counter accumulated value is less than 10. I want to know when it's between 10 and 20 and when it's above 20. So we'll be able to do other things with this accumulated value later on as an integer. But for right now, we're going to concern ourselves primarily with the done. So here's our counter address, our preset, and then we'll have an accumulated value just like we did before. So the count up instruction, the way the count up instruction is, I have a CU pin, or like an enable pin, but it's a CU pin. Every time that CU pin makes a pulse, boom, a 0 to 1 transition, 0 to 1 transition, 0 to 1 transition. The accumulated value is going to increase by 1, so plus 1, plus 1. So I've got 0, 1, 2, 3. Accumulated value is going up. And the done bit is going to stay at a 0. Okay, so this was a 0 to 1 transition on the count up pin. That's going in right here. This is my count up pin. Every time that pulses up, I go up by 1. So my accumulated value is actually going up, right? It goes to a 1, it goes to a 2, it goes to a 3, it goes to a 4, it goes to a 5, and so on. The done bit's going to turn on. In this case, I'm not going to draw out 1,000 of these, but when I get to the 999th, and then I get to the 1,000th pulse on that CU pin, that's when the done bit is going to go to on. Okay, so it's going to go 0 to 1. And just like our retentive, we either got to find a way to drive that count down, or we can take the reset instruction, and if we make that a 1, then our count and our accumulated value, even though it went to 999 here and 1,000 eventually, as soon as this reset, it went back to 0. Okay, and I'll show you a demo of this in a second as well. The count down instruction, very, very similar. In this case, I have a preset value of 1,000 and an accumulated value of 55. In this particular case, every time I pulse, now the accumulated value is going to go down, is what's going to happen. And then probably one of the most common uses of these two instructions is the CTUD. So by addressing a counter up and a counter down with the same address, what you can do is you can put a pin here, and then I can come down here and I can put my CTD right here with the same address, C5:3. And if I pulse this pin, the thing goes up. If I pulse this pin, it goes down. And again, if my preset value is greater than 1,000, then my done bit's going to be on. Okay. So let's do this counter demo real quick. All right. So go back into RSLogix, and instead of having an on delay timer here, I'm going to go ahead and grab a counter. I'm going to grab a CTU, place him right here. I'm going to grab a CTD. I'm going to place him right here. I'm going to grab another rung as well and place him right here. And I guess, well, yeah, that's okay because I want to use a reset instruction anyways. And then I'm going to grab a bit, and we'll do a, so instead of T4 now, we'll have a, I don't know what's my next address. Well, what I'll do is I'll go into my counter instructions, and I can see C50 is going to be my first address for this guy. C51 will be my address for this guy. Okay. And I will make this is I00, so this will be input 01. I got 02 on him. We'll make him 01. Oh, and I know why, because it's addressed in here. I'll make this one 02. All right. And now I'm going to put my reset, and actually I'm going to get rid of this. I'm going to keep it simple for right now. Let's put this reset instruction on C50. All right. And then instead of a T4 done bit, because now we're dealing with a C5 or a counter, I can go into my counter data files, and I can grab the done bit for C5 and throw him in here. Okay, you can see I have a CU pin, count up pin, count down pin, done bit, overflow, underflow, preset, accumulate. I got a bunch of stuff. Some of that stuff we're not going to use yet, but we will here in the near future. I'm going to put a preset on this of 5. I don't want to flip it 10 times. And then I'm going to go ahead and download this guy. And first I'll verify my file. No errors. Go to download. So here's my program downloading. I'll go online. I'll run it. Run mode. Go online. Now what we see is we see the accumulated values at 0. So the done bit's not on and my output's not on. So what I'm going to do in this run is I'm going to go ahead and flip this a couple times. Once, see the accumulated value over here went up to a 1. Twice, 3 times, 4 times. Now when I get to that 5th time, what we're expecting is we're expecting that done bit to turn on. So I'll flip it again. The done bit just turned on, and now our output is turned on. All right, I can keep flipping this, 7, 8, 9, the accumulated value keeps going up. I have no way to get that accumulated value down right now because it's only a count up counter. The only way I could get that accumulated value would be to flip this switch, I02, which would then be my reset instruction, which then resets everything. My done bit resets and my accumulated value resets. And then if I start flipping again, 1, 2, 3, 4, 5, the output's going to turn on again. And then again, I can reset with I12. I'm not going to go over the countdown individually. What I'm going to do instead, which I think will be a little more interesting for you, is there we go. Is instead I'm going to add a rung here, like we talked about a minute ago here. I'm going to add a rung here, and I'm going to put a countdown of the same address. So C5:0, and then I'm going to put the other bit on this guy, which will be I:1 or I:0/1. Okay, and so now the same bit this bit will count it up, this bit will count it down. I'm going to put a preset of 5 on both of them, and then we'll watch this done bit. We have the reset, we have everything. This is kind of the culmination of everything we're doing today, right? I don't have a timer in here, but I've got all my counters involved in one single program here. Downloading to the MicroLogics here. Go back to run mode, go online. You'll only see my counter value right now. In either one of these rungs, I can see my counter value is 0. If I go ahead and pulse input 0, see how both of the accumulated values on both of my counters here go up to 1. If I go up again, they go up again. If I get up to the point where they're at 5, the output turns on because the done bit's on, because I'm greater than the preset value. I can continue to go up. Now I don't have to reset though. So now I could use this bit then to decrement the counter. So I:0/1, and you'll see that counter is actually going down. And when it gets below 5, notice what happens. The done bit actually turns off now. I'm going to go back above. If I want to, instead of decrementing with this bit, I now am above and the output bit's on. I can always still use I:0/2 to reset it. And you'll notice because they both are addressing the same counter, the accumulated value goes down, the done bit goes away. So this is a great example of using CTU, CTD, same time. You know, I love this when you look at like a parking ramp. This is what they're doing. They're saying, okay, we have 500 spaces in the parking ramp. As cars come in, we increment the amount of cars that are in there, or we might even be decrementing the amount of spaces available. And as cars leave, we increment the amount of spaces available. But we use one counter to keep tabs of what's actually in there. Cars come in, the amount of spaces go down. Cars leave, the amount of spaces available goes up. Gives you some great examples of just one simple application where you might see this in the future. Binary files, reset instruction I don't need to cover, so we're good on that. We've seen the reset instruction a couple times now. Binary files, what I want to show you is, you know, when we've programmed up till now, you know, if I call this input 1, you know, input 2, and then I put a coil over here, and maybe I put a holding contact of that coil over here. For us, up to this point, the only thing we could have in this coil was an output. So we had to use an output address. It is possible to use a coil that is what I would call a virtual coil. It doesn't actually consume an output screw terminal. What we would do is we would address this as a B3 file. And this is a B3 file. So it's not actually consuming an output. But then I could use that B3 to turn other things on. Let me show you what I mean on this. For the binary files and why you might even care about this. So as an example, let's say we go offline here. And let's say I get rid of these counters, right? Boom. And I've got these two guys in series. And I want to use a coil to turn on all of my rungs. I want a coil that's going to, maybe it's even going to reset my counter or something too. But I want a coil that's going to energize all of my rungs for whatever purpose, right? Kind of like almost like a system run file or something like that. And so what I would do then is I would go into what we call the binary files. So we've used outputs, we've used inputs, we've used timers, we've used counters. Now we're going to go into the binary files. And I want to use a B3:0 on this guy right here. So you'll see B3:0/0. So instead of output 0/0 or output 1/0 or something like that, now it's a binary file. It doesn't actually physically connect to an output. But I could use that as my holding contact down here, right? I could, oops, sorry about that. I could have a holding contact associated with that binary file. So B, actually I don't even have to type B. I can just grab this address over here and drag him into here, right? Now I got a little B on there. Let's get rid of that. And then maybe I also want that B3:0, B3, I'll just grab the address again. It's right above me. It's easy just to grab onto that thing and pull it in. If I don't want to do that, I could also go get that address, right? Because we have it in the binary data files over here. So I can go get that B3:0/0, which is right here. Boom. So that's the same address. And maybe, when I do this, maybe that's gonna reset a timer. Maybe it's gonna reset a counter. In my case, I'm just gonna have it turn on something. I'm going to have it turn on an actual output, so a binary file turn on an actual output. There we go. But what's neat about this is when I turn this on, I'm going to energize this guy over here. I'm going to pretend this is like a start-stop station here. I'm going to energize this guy over here. He's going to put this holding contact. But remember, the binary file doesn't actually consume an output. So if I want to turn something on that's going to start other things, maybe I want this happening to start a timer. Maybe that's what I want, or not a counter. I want to start a timer with it. So I'm going to have a timer over here that's going to time for, T4:0, and it's going to time for 5 seconds. So instead of having to have an output address start my timer, I just want this binary file to start the timer, and then that can go over here. And maybe that timer then can turn on. So again, my timer file here, the done bit associated with it. That guy then could turn on an output. So what's nice about this is normally if we'd have done this up until now, what we'd have said is we'd said, oh, well, I'll have an output. So these two switches, and I'm actually going to get rid of some of these things here. Hold on. There we go. There we go. So we'll just do this. So when I energize this, the binary file is going to start the timer. Instead of having to consume an output address here and then not wire anything up to it to start a timer, now this binary coil, which is a virtual coil, will start the timer, and then when that timer times out, I'll be done. So I'm going to verify the file here, make sure that these binary files look good. They do. I'm going to go to download, hit OK. It's going to run. It's going to online. Go back to run, go back to online, and oh, I'm already on here, so I'm going to turn this off. I don't want to turn it on yet. So now when I turn this bit on, the binary file is what's going to start the timer. I don't have to consume an address of my outputs. So I turn this on, binary file energizes, my timer starts timing, and when the done bit goes, the output turns on. So kind of a neat way to do this. You might say, well, you wouldn't have had to do that, EJ, right? You could have just put that input on the timer. Well, of course. But what if I want, multiple different things to be able to turn that on, or if I want that binary file to do several different things in my program, I could do something like that as well. So I think that covers the gist of what I wanted to hit on this particular lecture. So that covers timers and counters. And obviously we're going to go a little bit deeper when we get into lecture, but this should give you at least a really good preview of what we're going to do.